With the layered architecture explained, what I'm showing here is the software side of the internet side by side with the hardware of the internet. So where are the hardware in this example? Look, here, and here. So these are end systems, okay? This one is the source and this one is the destination. You see that at the end systems, the entire internet protocol stack is implemented and running. Similarly for the other end system. But in the core of the internet, you see the router over here. And this is a very special entity, hardware entity. It's called switch. But to be precise, this is the link layer switch. Its functionality is limited. Okay? Unlike router, this is a network layer device that implements the protocol stack from the lowest up to the network layer. The link layer switch is a more limited device. It implements only from the physical to the link layer. Well, then you see how it gets the name. It's a link layer switch. And if you want to be precise, you can also call these routers the network layer routers. Or sometimes we actually call these routers network layer switches. Okay, so both of these entities are doing switching, but doing the switching at a slightly different level. Alright, now walk with me and let's see how the data gets passed down the protocol stack, out of a physical entity, and through the network, reaching the destination. The first step is this. One particular user typing things up. So at the application layer, this component generates a message. A packet at the application layer is referred to as a message. The application layer component will pass the message down. As the message arrives at the transport layer, a header is being appended in front of the message. Okay, because it's appending, therefore these additional pieces of information is referred to as the header. H stands for header. And this is a header appended by the transport layer, therefore HT. The whole thing together, this packet, is referred to as the segment. So a packet at the transport layer is called a segment. And you see that this header here is very important. This is to allow the transport layer component at the source side to communicate with the transport layer component at the destination side. Okay, so this is a little bit like at the airport. When we're checking our bag, the counter is going to give us back what? The passport, the e-ticket, and what? The baggage claim ticket. Okay, so that baggage claim ticket, that additional information, okay, in order for you to find your bag, is a little bit like the headers. Okay. And now the segment is going to be passed further down to the network layer. And guess what? The network layer component is going to append some more information to it. And that is in the header as well. But this is the header for the network layer, HN. And the whole thing now, the packet here at the network layer is called a datagram. And the whole datagram is going to be passed down further to the link layer. And guess what? The link layer header is going to be appended, and we call a packet at the link layer a frame. So this frame here, now arriving at the physical layer, what physical layer is doing is simply modulating the 0 and 1 bits, okay, onto the physical media. So it's going to go out shortly through the network interface and arriving at the router here. Now I'm skipping the switch here because it's a link layer device. We'll not be able to cover the link layer chapter. So this message is going to arrive here at the router receive at this physical layer, and the signals gets converted to the digital form. So we restore the original frame back, and that's passed up into the link layer. The link layer at the router is going to examine this header and see if there's any additional function that it needs to perform. When everything is done, guess what? Okay, this header is going to be removed. So only the message with the transport layer header and the network layer header will be passed up to the network layer. You see here, the message is being passed upwards, okay? Because the network layer component of the router still needs to check this, okay, and see if there's something that the network component needs to do at the router. So this is going to be examined, okay, and functionalities performed. Now this part, hey, as this is a router, there's no other layers above. So this is going to be copied over, okay, and stand by there at the outgoing interface. Now before that message go down to the lower layer, the new network layer header is appended. And this one is a datagram. It gets passed down to the link layer header appended. And this is a frame. It goes to the physical layer. Bits modulated, traveling the link and reaching the destination. Similarly, the physical layer is going to recover the 0 and bits and give this up to the link layer. This checked by the link layer, and the remaining gets passed up to the network layer. And you see this removed, this part gets passed up to the transport layer. This removed, and this part here gets passed up to the application layer. And here, the destinations processed there at the application layer finally see the message coming from the source originally. So this is how a message travels through the protocol stack and the physical infrastructure and more protocol stack up and down until all the way up to the application layer and the destination.